Okay, hello everybody and welcome back. We start chapter 5 today, this week. Trigonometric functions. This is pre-calculus. We just did exponential functions, log functions, and now we're doing trig functions. For calculus, that's where your language is going to be located, most of your thing. Trig stands for, let's see, triangle geometry. And that's what it is. It's a bunch of it's about a bunch of triangles. You can actually derive all of trigonometry if you know the Pythagorean theorem, and you put it, and draw circles. And it's a model. Trigonometry is a model for anything that happens over and over again, such as the tides, the ocean tides, or the moon comes back. It's called a periodic function. It happens always periodically, and several things in life are modeled by these periodic functions. And in order to get there, you need trig. And so that's where we're headed today. And in order to start talking about trig, the whole thing is based on an angle. So, like, what's an angle? You know, everybody has an intuitive notion of what an angle is, but it's two rays with a common endpoint. And it doesn't matter. Endpoint. And that endpoint is called a vertex. And there's a ray. A ray is a line that has an endpoint, and then two rays, they share the same endpoint, and so that's an angle. And what we do with angles is we talk about this spread. And right now I'm going to use theta. We'll get much more about the way we're going to note angles, but this is theta. And it looks like that. And so that's the independent variable. That's what's going to change in trigonometry. This is the independent variable, and then as that changes, we'll have function. We'll create functions. And on trig, the vertex is the origin. I mean, when we start trig, the vertex is the point 0, 0. And then this is called the initial ray. And it's always on the x-axis, positive x-axis. And this is called the terminal ray. And that's what's going to change. The initial ray will be right here. This is about a 60-degree, and then we're going to go back to here, over to here. There's 90 degrees. This terminal ray is the thing that'll change. And so what changes when the terminal ray changes? The measure of an angle. Of theta, an angle, theta, the angle. And like I say, I'm going to be using theta quite a bit. So we'll just stick with that for now. We'll talk later about notation. And so there's two ways to measure an angle. There's degree measure. And a degree measure is based on the Babylonian number system in which we created our clocks. Minutes and seconds, there's 60 minutes to an hour. And there's 60 seconds to a minute. All that is based on 360 degrees is a full circle. And this is arbitrary. I mean, it's just like a foot or an inch or certain standard measurements. It's just completely arbitrary. But so that's 360 degrees. And so here's an angle. There's the initial side. Here's the terminal side. If the whole thing's 360, well, that's divided by 4. So 180 is half the circle. 90 is a quarter of the circle. Is half. And 270's down here. We want to know about, like, here's 30. And right here is 45 degrees. Those are very important angles in trig. Again, you can derive it if you just know a little bit about these triangles. Because that's what trig is. Eventually, we're just going to drop a perpendicular. That comes next video, actually. And so this is an angle in standard position. It's called standard position, meaning that the initial ray is on the x-axis, positive x-axis, and the terminal ray it is moving, actually, but it stays on that. We will talk about the radius of the circle quite a bit. Okay, so let's see where we're headed from here. And so we measure it in degrees, and everybody knows, oh, 90 degrees, I know what 90 degrees is, I know what 45 degrees is, but it's arbitrary. Rather, another measurement would be in radians. And this is mathematically correct. Radian measure. And what a radian measure is, it relates the length of the radius to an arc of a circle. Here's a circle, and what I'm saying that here's the radius of the circle, which never changes along this circle. And what 1 radian is when this length, we'll call it r for radius, is equal to that length. We'll call it s for that arc length. And we're going to talk about how to measure arc lengths. But so a radian, this is 1 radian, and it's approximately equal to, by the way, 57 degrees. It's about 57 degrees. But now think about what we're talking about. So that's 1 radian. Boom. Over here or so is 2 radians. You know, that's 2 radians. You know, down to whoops, I missed 2 radians. And right here is about 3 radians, 3.14 radians. So 180 degrees is pi. There's 1, there's 2, there's 3, there's the 0.14. The whole thing is 2 pi radians. And we don't even write the word radians because that's the way you do it. When you put degrees, you have to put degrees there. Here, this is mathematics. That's the number associated with the measure of any angle. So what we do, one little thing, let's talk about quadrangles, little definition. Quadrangles they're called. And they are when the terminal side is on an axis. Side of an angle is on an axis. And so what we're saying here is a circle. There's 4 quadrangles before you keep going around again. Here's 0 degrees. That's a quadrangle. And the sorry about that. The angle, that angle, 90 degrees, is a quadrangle. By the way, that's pi over 2. Because 180 degrees is a quadrangle, but that's pi. 3.14. 1, 2, 3.14. Here's 270 degrees, which is 3 pi over 2. And of course, here's 2 pi, 0 degrees. Or 360 degrees. And in trig, there's no stopping. You just keep going. By the way, we'll talk about reference angles as we go. So that's what happens. And that's just the definition of trigonometry for the most part. We haven't really done anything yet. I think I'll stop and, yeah, let's stop here. That's interesting. I'll be right back.